the cloud. Okay. So we left off on Monday on other sampling techniques. So this one is just giving you an example. In the population of all undergraduate college students, some strata might be freshmen, sophomores, juniors, or seniors. Other strata could be men or women, in-state versus out-of-state. I think you're getting the idea. It's just basically how we group things. Then a simple random sample of a certain size is drawn from each strata. Okay. So groups or strata are often sampled in proportion to their actual percentages. Basically, you'll be able to have a Q and a P. And if you're given one, you should be able to predict what the other should be. Okay. Systematic sampling. This is a method that we use where we assign some form of a natural sequential order. So the example they give here is people lining up to buy rock concert tickets. Obviously, if you have ticket number 1, you're going to be ahead of someone who has ticket number 500. Right? Okay. Before we get to it, what do you think could be one of the dangers of using systematic sampling? Think about what that technique is, and then maybe think about an example you might use with it, and then that might help you figure out what the danger could be.
Well, even though the people are chosen at random, in doing so, you have the chance that every single person you choose is of a similar demographic, or they have some similarity between each other, that it's not representing the entire population equally.
Okay. We could also have the converse of that, right? Like we could end up having where you said the people could be similar, but they could be similar in a way where you're not getting anybody in the desired group that you want. Okay. Let's see. Yeah. So this is kind of giving you an example of that. When a population is repetitive or cyclic in nature, systematic sampling should not be used. For example, consider a fabric mill that produces dress material. Suppose the loom that produces that material makes a mistake every 17th yard, but we check only every 16th yard. So you're never going to catch the mistake. All right. Okay. Here's another kind. Cluster sampling is a method used a lot with government agencies. Pretty much it's where we select sections or clusters. Everyone within a certain borough could be selected. A lot of times they use this with like crime stats, which is a lot of times why certain people pretty much tend to fight those crime stats. Obviously, if you're only gathering it from a certain area, you're clearly going to have a little bit of a bias there. Okay. And I promise not all of this class is big, ginormous information like this. We just have to get some of the intro stuff out of the way. Okay, often a population is very large or geographically spread out. In such cases, samples are constructed throughout a multi-sample design of several stages. So here's our example. The government current population survey interviews about 60,000 households across the US each month by means of multi-stage sample design. The first stage consists of selecting samples of large geographic areas that do not cross state lines. These areas are further broken down into smaller blocks, which are stratified according to ethnic and other factors. If stratified samples of the blocks are then taken, finally the housing units in each chosen block are broken into clusters of nearby housing units. So a random sample of these clusters of housing units is selected and each household in the final cluster is interviewed. That's a lot. Can anyone see where that scenario could kind of go wrong for someone? Okay, so let's think about it. So the first thing they did is they found their geographical region that didn't cross the state line. So they might have, they could have up to 50 of those, right? We have 50 states. They then broke it down into smaller blocks. But look at what they used to figure out their breakdowns, ethnic and other factors. So is your sample really going to be comparative? What would a better approach be to making a comparative sample there? What do you guys think? I don't know if we have reactions on this, but if you at least have reactions on this, let me know. Do you agree or disagree? If we were to break it into stratified, once we got to those blocks, instead of thinking about ethnic factors and stuff like that, what if we just literally just found a more mathematical way of doing it? You take the people aspect out. You don't really look at, who's living on the block. You just pull the block. If you're doing that, you're probably going to have a higher chance of seeing a more generalized outcome than just, the factors that they're used to using. Okay. You will find that with statistics, this is just a side note, a lot of the times you're going to find that people can use statistics to pretty much kind of say whatever they want. They'll have something that they're trying to prove, and they can use stats in a variety of different ways to make themselves look like what they're saying is true. So you really have to be vigilant in knowing what your stats are saying, so that when someone else is trying to give you a statistic, you know whether they're using it kind of maliciously or, if they're being genuine about it. So I guess if you take nothing else away from this class, that is something that I would really, really strive for you guys to take that away from this. Being able to kind of know when someone's just using it to kind of pull one over on you versus using it in a way that's genuine and true. Obviously, I'm hoping you'll take away some of the mathier parts of it too, but if nothing else, just don't let yourselves be tricked. Okay, so convenience sampling. This is where we use results or data that are convenient and readily obtained. So if we look at something like supporting the arts, we don't really want to survey necessarily an art gallery. Obviously, everyone going to an art gallery, I mean, unless you're, the partner who's not really interested in art and you're trying to get brownie points, so you show up and go, more than likely you support the arts, right? But that's just kind of a convenient option. And again, that's kind of where people like to use their knowledge of stats to help them. A better option would be if you were trying to see how many people supported the arts, but you went to a sports event and vice versa. Okay. But that wouldn't be a convenient sample. I'm just letting you know that that would be the better option for you as the statistician. Okay. We call the list of individuals from which a sample is being selected the sampling frame. So the frame is the entire population. Okay, so that one's probably a little bit hard to wrap your mind around since we're used to samples being within the population. Okay. When the sample of a frame does not match the population, we have what is called undercoverage. So again, you have two vocab words there. I want to say that some of your vocab does show up in your exams since I made your exams kind of shorter. So I would probably, if you're not going to take like notes from what I say during class, either watch the YouTube video afterwards, or if you have the textbook, definitely take notes from it. If you have the textbook, you should take notes in advance so we can have some conversation. All right. Okay. In general, even the sampling frame and the population match, a sample is not perfect. So we can end up having what is called a sampling error. This is when the sample information does not match the corresponding population information. Okay. You will have to figure out sampling error. There is a formula attached to it. I just don't think you have to worry about it in section 1.2 because if I remember correctly, we only have one more slide and I don't believe it is a formula. Okay. It is more notes. Okay, so sampling error, like I said, is the difference between the measurements from a sample and corresponding measurements in the population. It's typically caused by the fact that the sample does not perfectly represent the population. A non-sampling error is the result of poor sample design, sloppy data collection, faulty measuring instruments, bias in questionnaires, and so on. In other words, human error a little bit. Actually, human error probably accounts for most of that. Bias in questionnaires, you will see hopefully less of now. Can anyone remember, it's not really a questionnaire, but there was a very big kind of issue with a certain test that was considered biased. Does anyone remember what it was? You guys might not have to take it. Just depends on when you're graduating and what's up.
Is it the SAT?
Yep. So I think it was back in the 80s or 90s. A bunch of people basically got together and said that there was a huge bias in the SAT questions. A lot of it kind of showing that pretty much you could only really know the answers if you were going to school in a certain environment. So I'm not really sure if it's been changed. One would hope that it has been, but obviously not 100% sure. So, and clearly we can't just kind of refuse to take a test based on bias. You just kind of have to do the best you can. The little side trick I will let you know is that with how the SATs are graded, it is actually better for you to leave a question blank that you can't immediately answer, or you can't cancel out options, because if you guess incorrectly on the SAT, it actually takes away points, whereas if you leave it blank, it's null and void. It's like a 0. It doesn't count for you or against you. Obviously, you cannot leave the entire test blank. That would not behoove you to do. But if you can make an educated guess, you should do so. Okay. Any questions on 1.2 before we go into 1.3? I know 1.2 is a bit heavy on the writing and just verbiage. A lot of it dealing with the different sampling techniques, but I cannot recall at the moment when the switchover happens. I want to say chapter 3. We slowly start to see a little bit more math coming in. So, all right, introduction to experimental design. And of course, by math, I meant your more traditional math, formulas, numbers, etc. Okay, so our discussion points that we're going to talk about today, discuss what it means to take a census. I think we've already talked about a census, so I'm pretty sure you guys are well aware of what that is. Simulations, observational studies, experiments. We'll talk about how to identify control groups, placebos. All right, you get the gist. Whoop. Okay. Planning a statistical study and gathering data are essential components of obtaining reliable information. Why can we not just say that something we feel is true is true? Like, go ahead. Like, why can't I say, given my experience as a college instructor, I know that students who show up to class every day, take notes, and participate will do well than students who skip class, don't take their notes, and turn their work in late. Why can I not just blanketedly say that?
Because it's not true for everyone.
Right. So just because the majority of my experience is saying one thing doesn't mean I can't have someone who would be completely fine going through all the homework, just doing the homework, and then taking my exams and getting an A. Or, yeah, I guess an A, because I will let you know that the participation in this class does not have an actual percentage, but I definitely pay attention to who's doing what. And so if you come to class, you'll probably get helped out a little bit here versus not coming to class, if that makes any sense. So yeah, what I can tell you is that a lot of research was done in the fall semester based on, of course, us having to go into COVID mode in spring of 2020. So what some of that research showed is that students who are in Zoom classes and actually have their cameras on tend to have a higher grade in the course than those who do not have their cameras on. Now, obviously, again, you're looking kind of at a generalization, but that is a generalization that actually has data supporting it. If you want the study, I'm sure I can find it. I think they sent it to us, because I won't lie, other than a disembodied voice, I don't kind of care about the camera, because I kind of feel like everyone's an adult, and if they don't want to show up, they won't show up. But I did have one student, I guess as a side note, I'm Italian, so it's going to happen. I did have one student last semester who had his camera on and then, put like the away picture up or whatever. And it was a smaller class. It was a trig class. So I think I had less than 10 students in it, something like that. Definitely less than 15. And I remember like kind of towards the end of it, I asked a question or like asked him a question, and I just kind of waited for a minute, and then I wrote it in the chat and I waited, and then I finally got tired of waiting. And later he ended up coming back saying that he was in the bathroom. I mean, obviously I don't really care if my students go to the bathroom, but I mean, I really hope his plumbing was okay after 50 minutes. So, yeah. But yes, I mean, the stats are definitely out there. Students who participate and show up and do what they're supposed to do, just like in any normal class, they tend to have higher grades. I can't really tell you why, because I didn't read this study. I won't lie to you. I did not read it. I just kind of took the basis of what they were telling me and said, okay, sure. I don't really need the details of it. Okay, so this is a basic procedure for planning a statistical study. You can write this down or you can take a screenshot, whatever's easiest for you. You definitely want to kind of pay attention to this because even though I don't have it up yet, I tend to like projects better than exams. I just don't really want to overwhelm you guys because this class has a lot of assignments in it. Way less than there used to be because I cut a lot of it out. But I don't know. I just feel like a class like this, it's so much better to work hands-on. It's just kind of obviously hard with us being in 10 different places. Okay, so here's the first thing you're going to need to do. We have to identify the individuals, participants, or objects of interest. So if you don't know who or what you want to study, obviously your statistical study is not going to be going too far. Okay, you want to specify the variables as well as the protocols for taking measurements or making observations. You want to determine if you will use an entire population or a sample. If using a sample, you have to decide on a viable sampling method. So typically, even though you end up working with samples, it's obviously easier if you just say that you're going to work with a whole population. So for my class last spring, they did a semester-long project that replaced their final exam grade. And basically what they did is they had to create a way, an object or something to do on campus that they could increase student enrollment and retention. They did a really great job, but we were located in Tamaqua. So they chose that student body as their population. Now, they obviously didn't get every single Tamaqua student to participate, but that was the initial goal. So as long as they basically were able to say that they weren't just taking a subset of the Tamaqua campus, but they were actually hoping to poll and did give opportunity for all students to take part in the study, they were allowed to do that. So number 4 is data collection. So you have to be able to address issues such as ethnics, confidentiality, privacy. If you're collecting data at a business, store, college, or other institution, you have to be conscientious of obtaining permission. Let me tell you, that is no joke. I thought my project, because we weren't really going to be publishing it, that we could just kind of do it. And the answer to that is no. Everyone in the class had to sign it's like a 6-page packet. I can probably email it to you guys just so you can kind of have an idea. It's definitely worth kind of having the idea. If you guys go off to like a bigger school, I don't know, Penn State, UPenn, wherever you decide to go, anytime you're thinking about doing a project, you have to get permissions. It's just the way it is. Then once you are approved, which this is kind of where we took some liberties, we turned in all the paperwork, but we didn't really wait for approval. We just assumed we were going to get approved, and no one really got a hold of me saying otherwise. So we took that as silence was their approval stamp. And then of course with COVID hitting, we just took it as a go forth and learn. So once you're given your approval, then you have to collect your data and then use appropriate statistic methods that you are going to learn about in those chapters to kind of make your conclusions. All right. Anybody have any questions on like the general idea of what a statistical study is? Okay. I can tell you that any study you may have heard about has had to go through all of these points. I hope that was the next slide. Okay, it is. All right. Census is a measurement or observation of an entire population. So most of us know about the census from where?
Like the US Census.
Right. So history class, right? You tend to know what the census is because they'll say like in the 1902 census. That's not true. They kind of do it every 10 years. So I don't think it would be 1902, but whatever. Yes. So we have a census in the US. Obviously, or I guess I would assume other countries also do censuses. They have censuses. Yeah, whatever. They take them. All right, if we use the data from only one part of the population of interest, then we have a sample. Why your textbook chooses to repeat itself, I don't know. I can't answer that for you. I didn't write the textbook. My only thoughts would be that the more you write something, hopefully the more you remember it. But okay. So, experiments and observation. There is a difference between an observational study and an experiment. One of the biggest differences being that with an observational study, that's literally all you're doing. You are observing. Okay. So, you can't really observe sitting behind a table because you're going to have a bunch of people walking up to you asking you what you're doing. So when you do an observational study, you kind of really have to be truly invisible. You don't want to change environments. You don't want to interact with your subjects, for lack of a better word. You're truly just gathering the data. In an experiment, we're deliberately trying to make one specific change and seeing what happens because of that change. Now, there are different types of experimental designs. Does anyone know of any before we go over them? Anyone recall? I guess not really recall, but just from your own lifetimes. Okay. So there's this pretty fancy word that if any of you, well, I'm assuming you're allowed to watch it. I watched it when I was in high school, so not to throw my age out there. But so Criminal Minds uses a word called placebo sometimes. They're like, oh, Reed's so upset that his mom's got the placebo, so he is ridiculous and takes her out of the nursing home. Never do. Don't do it. So yeah, placebo. What those are typically used in are called blind studies. So we can have a double blind or we can have a single blind, but you have the actual medicine that you're using, the actual item that you're putting in and seeing the change for. And then you can't just give the other group nothing. It's not like you can give them gummy bears or, Sour Patch Kids and say, this is this is what we're giving to the other group. You can't do that. So you have to give them a placebo, which is typically a sugar pill. They typically look pretty much identical. They make them look identical. And I mean, unless you're in the study and you have diabetes, you're probably not going to have a huge effect just getting a random sugar pill every day. Okay, so here's our example for an experiment. In 1778, Captain James Cook landed in what we now call the Hawaiian Islands. he gave the islanders a present of several goats, and over the years, these animals multiplied into wild herds totaling several thousand. They eat almost anything, including the famous silver sword plant, which was once unique to Hawaii. At one time, the silver sword grew abundantly on the island in Maui. I am not going to try to pronounce that national park. The silver sword can still be found, but each year there seem to be fewer and fewer plants. Biologists suspected that the goats were partially responsible for the decline of the plants and conducted a statistical study to verify their theory. Okay, so to test the theory, park biologists set up stations in remote areas of the park. At each station, 2 plots of land similar in soil conditions, climate, and plant count were selected. One plot was fenced to keep the goats out, while the other was not. Oh no, I'm so interested. At regular intervals, a plant count was made in each plot. This study involved an experiment because a treatment, aka the fence, was imposed on the one plot. The experiment involved 2 plots at each station. The plot that was not fenced represented the control plot. This was the plot on which a treatment was specifically not imposed, although the plot was similar to the fenced plot in every other way. Okay, so do we kind of see that we cannot make any more than one change? So this is something that you really have to kind of get a huge grasp on. So a lot of times when people are going for their PhDs and they have to think about a dissertation, one of the things that hiccups them the most is that they kind of have scatterbrain. They're all over. They don't know really what they want to research because for the past 3 years, they've been learning about everything. You have to have a very concise and succinct idea for what you want to study. So if we end up doing a project or a paper instead of one of your tests, you can't really come to me and say, well, this is my idea, and then list 3 to 5 things. Because here's what happens if you have more than one change, if you want to impose more than one difference, what do you think happens?
If you change 2 variables and something does change in your control group and your experiment, you don't know which variable was the instigator.
There you go. Okay. So, and it would just be kind of too confusing, although they do it at times. If you wanted to have multiple groups, but the problem with that is that you'd almost have to have as many control groups as you do experimental groups. So when people have ideas like this, they typically just use more than one study, and then they present their conclusions over multiple studies instead of, all within one. So it's just going to take them more time. Okay. Statistical experiments are commonly used to determine the effect of a treatment. However, the design of the experiment needs to control for other possible causes of the effect. Here's a good example. In medical experiments, the placebo effect is the important improvement or change that is the result of patients just believing in the treatment, whether or not the treatment itself is effective. So obviously, I mean, we would all love to believe in the power of positivity and positive thinking and everything else that comes out of amazingly happy thoughts like that. But clearly, if we have a control group getting a placebo and another group getting a not yet FDA approved drug, then you can't really positive idea away cancer. So, I mean, people in the placebo group could have better, they might present with a healthier attitude, but their chemistry is probably still going to be the same. They're still going to end up having, whatever was wrong with them to begin with. Definitely take a note for the placebo effect. This is just kind of telling you what we've already talked about, that in order to use the placebo, we divide patients into two groups. One group is prescribed the treatment. The other group is called the control. It receives the dummy or placebo treatment that is disguised to look like the real treatment. Excuse me. I think the only thing I would change about placebo experiments would be if the treatment does actually work, then I would like to know if test groups give that treatment to the control group after the experiment's over. I feel like pharmaceutical companies don't do that, but I definitely feel like that would be the right and humane thing to do, especially if you're considering that you have an entire control group that was sitting there thinking they were getting better, and now they might be sicker. So, personal opinion, take it as you want, but that's my thoughts on that. Okay. Finally, after the treatment cycle, the medical condition of the patient in the treatment group is compared to that of the patients in the control group. Common way to assign patients to treatment group and control group is by using a random process. This is the essence of completely randomized experiment. Let me tell you why this is important, and I think at this point you guys will actually watch. In Grey's Anatomy, don't ask me which season, but we all remember whenever Meredith decided to take things into her own hands, and apparently it was quite a while ago, because she potentially could have completely ruined Derek's brain aneurysm trial or whatever trial they were doing. And she kind of got too personal and decided to place a subject into the experimental group, treatment group, and not into the control group. Completely unethical, completely not her place to do it, and yet she did it anyway and barely got a slap on the wrist. So, extremely important that you do not pull a Meredith Grey and decide to just put people wherever you want to put them, because here's what ultimately ends up happening. You will, without a doubt, because you are all really great human beings, have a much larger treatment group than you will have a control group. You cannot have this. Everyone must be equal. It has to be completely unknown to you, which is why the double-blind experiment is probably best for cases of medical trials. Okay. I think my example was good enough. I don't think we need to go through and read that. We can take a quick look at this little chart here. So we start with patients with chest pain. They're randomly assigned. Notice the groups are identical, 149 and 149. Why they wouldn't do 150 and 150 to make things nice, I have no idea. Treatment 1, laser holes in the heart. Okay. Treatment 2, no holes in the heart. I don't know about you guys, but I would probably want to be in treatment 2. Compare pain relief. So I'm sure that the laser is supposed to be a good thing, but I wouldn't want that. It seems scary. So, but you can see that it has to be equal, right? It is difficult to control all the variables that might influence the response of a treatment. One way to control some of the variables is through blocking. A block is a group of individuals sharing some common features that might affect the treatment. In a randomized block experiment, individuals are first sorted into blocks, and then a random process is used to assign each individual in the block to one of the treatment groups. I don't really know if I've seen an example of that. that I can give you experience from. So I guess if someone wants to do some research on your own, you can see if you can come across that, but I've never heard of it actually being used. Okay, so we know we have a control group. This is the group that receives the dummy treatment, okay, or the placebo effect. In general, a controlled group is used to account for the influence of other known or unknown variables that might be an underlying cause of a change in response in the experimental group. Some of those causes are often called lurking or confounding variables. Huh. Okay. Yes, Celine did just chat with me and tell me that it was the Alzheimer's trial, which I should have remembered because of Adele and Meredith's mom. But right now I've got Criminal Minds on the brain, so the only one with Alzheimer's is Reed's mom. No one else exists right now. Okay, randomization is used to assign individuals to the two treatment groups. This helps prevent bias in selecting members for each group. Replication of the experiment on many patients reduces the possibility that differences in pain relief for the two groups occurred by chance alone. Okay, so replication, let's talk about that for a minute. So typically you will not have to, I guess that's not the right phrasing I want to use. So if you're going to go into research in kind of any field, something you want to keep in mind is we care about something called validity. And in order to get validity in a research area, you have to basically be able to show that what you've done can be replicated. And when it is replicated, those results will be very similar to the results that you came up with. So a lot of times researchers will actually replicate their own work, if for nothing else than to validate what they've already found to be true. All right. Surveys. Well, I guess before I go on to surveys, does anyone have any questions regarding experiments? Either, well, I guess studies, either observational or experimental. Which one do you think is more fun?
I'd hope experimental.
Right. And then which one do you think is harder?
Touche.
Mm-hmm. So, I would say that so in terms of coming up with an idea, I think experimental all the way. You guys can probably come up with experiments all day long. In terms of actually completing something on your own, I would probably say start out with observational, but honestly, we all know we want to have more fun, and isn't it worth having more fun, even if it's harder? So experiments probably would be my pick too. Unless I got to sit and watch like a bunch of TV shows and compare those, I'll observe that all day long. That's okay. All right. So surveys. This is something you want to get to after you've already done your preliminary work. So you've already done kind of like your lit review. So you've done a whole bunch of research with what's out there already. You've kind of narrowed down what your research is going to be about, whether you're going to do observational or experiments or what have you. Now you're on to the stage where you're kind of going to get some of your intro data. So I will let you know that in an experiment, you're not going to have just one round of data collection. That doesn't happen. You you first have to find people that want to be in your study. So you have to kind of survey them. And you also have to not only survey them to find out if they want to be in your study, because you can't just have a pointed question like, would you like to be in this study about blah, 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 blah? Because the whole point of what we do is we kind of want to observe, either whether observationally observing or experimentally observing, but we want it to be this third person, this third object out in the open in space, and we don't want to have an influence on our participants. So you really know if you're doing a good job as a researcher if at the end of the either at the end of the statistical study, if the participants can't really tell you what you were studying, then you know that you did things correctly. If at the end of it, someone can sit there and say, well, clearly you were asking me to figure out blah, 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 and they basically hit your hypothesis on the nail, you messed up somewhere. It's not supposed to be where they can figure that out. And for another tangent, since I have so much ADHD today, does anyone know when you take a survey, the worst thing you could do? What's the worst thing you could do in a survey? You can consider it the course evaluations at the end of the semester. I don't know what other surveys there really are. Those are the ones that are important to me. What do you guys think can happen? Oh, I know. I often take surveys for like if I bought something, or if I worked with a company and they send me like that's a satisfaction survey, like, were you happy with our product or our customer service or whatever? What is the worst thing you can do other than leaving it blank?
Lie.
Yeah, lying's not good. Yeah. So I'll tell you, statistically, the worst thing you can do is, do you know how sometimes when you're just in a hurry and you don't really want to do something, so you just go straight down and you either give them all 5s or all neutrals or all, your company made me mad, so I'm going to give you a crappy review and you get all 0s. Okay, when you give all of whatever, they basically throw it out. They assume that you didn't want to take the time to do it, so then they don't count you. If you really want to give either a really good review or a really bad review and actually be counted, you have to pretty much give a range within the crappy scale or a range within the good scale in order to actually be counted. So if I have a really awesome professor, then I don't want to go down and give them straight, excellence. I want to go, so here's all the instructor questions. Those I'm going to give all excellence. Why not? And then here's some questions about how the course was set up. I'll give that a good or an okay. Here's some questions about the publisher and the textbook. Well, the textbook was kind of crappy, so I'm going to say it's crappy, or whatever. So that is how you actually want to get your survey to be good, but then also be counted. Okay. I can tell you, I wish someone would have told me that when I was going through school, because clearly having my course evaluations thrown out as a student was not awesome. I don't think they actually can throw out your course evaluations, even if you don't take my advice on how to answer them. But I can tell you that someplace like Walmart or Target or any other major corporation that you might do a customer survey for, they don't care and they don't need your negative review. So they will just ignore it. Okay. So that was a lot on surveys. The Likert scale, that is the scale that you actually see on surveys. Sometimes we have open-ended and discussion-based responses. Those are kind of hard for you in the sense of being a young researcher. What you kind of have to do with an open-ended response is you have to find a way to categorize it or give it a number value. So like your best open-ended options will be for them to say yes or no, but if that's the case, then you might as well just give them a yes or no clicky button or, checkbox or whatever. Um, I'm trying to think of like a good example. If I can come across my old thesis work, I will show you guys some open-ended responses and how I coded it. It just might take me a little bit to get my hands on it. But basically, that's what you do. If you have open-ended responses, you as the researcher, you have to code it. So I'm not talking about like regular computer code. I mean like, so one response, let's say it's a negative response, you're going to give it a 0. And a positive response, you're going to mark it as a 1. And that's how you're going to grade them, basically. Okay, so some pitfalls to surveys. We're all we've probably all done one or the other of these things as a participant. The non-response, I can tell you during any time for politics, they all go in the trash for me. It's just absolutely ridiculous. I don't fill out any of it, and I wish they could just lose my address or my phone number or everything. And my favorite thing to do during anything political is the blocking game, where they call or they text me and I call and text them back and then I block them. It's so much fun for me. I just love that I spend so much of my time doing that. Truthfulness of response. Respondents may lie either intentionally or inadvertently. Tiffany pointed that out. You don't want to lie. So obviously we know people do. Faulty recall. Respondents may not accurately remember when or whether an event took place. That's probably happens more rare, only because I can't really think of any research where you would need to know that. Hidden bias. This happens a lot. The question may be worded in such a way to elicit a specific response. The order of the questions might lead to biased responses. Also, the number of responses on the Likert scale may force responses to not reflect the respondent's feelings or experience. That happens a lot. I don't know about you guys. How many of you have jobs right now, or had jobs before COVID? But man, I can remember some of those like Walmart and fast food jobs where you had to sit there for like an hour and answer these stupid personality tests where you're just like, I'm not on a dating website. I'm trying to get a job. Why do I have to answer all these personal questions? Ridiculous. Sometimes those will have a lot of hidden bias and they claim that it helps you get the job. I don't really think so. I mean, obviously you don't want a psycho on the fry line, but I mean, at the end of the day, everybody has to make money. So I guess, just try to keep your distance.
I've applied for several jobs at this point, and I can assure you they do not do that anymore.
Oh, good for you guys. Man, now I feel really old. But at least somebody took notice and switched that up. Okay, vague wording. Words such as often, seldom, and occasionally mean different things to different people. So what I want you to take away from this is if we do end up doing some kind of project along with what we're doing, which I might end up just emailing you guys individually and getting your thoughts on it, or we can just have an open discussion. I don't really care. When you're coming up with good, solid research questions or questions for your survey, when you're going through school to be an educator, they always hammer you on, do you know your Bloom's taxonomy? Which at this point, again, I'm old, so it might be a new thing now. They want you to kind of start things off with certain verbs. So this is kind of a similar thing. You kind of sit there and you think, well, I want to know how often someone thinks about blah, 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 blah. So take out the word often. How many times in a day do you think about, I don't know, wishing you were at home in your pajamas versus being at work in dress clothes? Who knows? It's a very odd research question, but whatever. You get the idea. Just ask them to be concise, and you will get a concise answer. Often, seldom, and occasionally, that can mean different for different people. So occasionally, to me, I think of like the holidays. That to me is occasional. Like it happens once a year. Seldom and often to me happen a little bit. Seldom happens more than occasionally, and often happens more than seldom for me. All right. Interviewer influence. Factors such as tone of voice, body language, dress, gender, authority, and ethnicity of the interviewer might influence responses. Unfortunately, interviewer influence is something that you're going to find very hard to control. You obviously cannot change who you are. No one would want you to. The only thing I can suggest there is to make your survey then on something like SurveyMonkey and email it out to people, because obviously then they're not seeing who the interviewer is, so they're not going to know to answer one way versus another or what have you. Voluntary response. Individuals with strong feelings about a subject are more likely than others to respond, such a study is interesting but not reflective of the population. So I think I mentioned the gaming on Monday. You know, obviously, if you walk into a game store and you want to do a survey about, I don't know, the newest release of whatever, you're gonna get a whole bunch of people in that store that's gonna talk to you nonstop. But then if you walk into a bookstore and ask the same survey questions, you might still get a decent amount of people, but obviously not everyone in the bookstore is there for fantasy gaming. You know, you're going to have them there for, I don't know, nonfiction, boring books. Okay. Sometimes our goal is to understand the cause and effect relationships between two or more variables. Such studies can be complicated by lurking variables or confounding variables. And I think we talked about these already, but I guess they're giving you the actual definition now. A lurking variable is one for which no data have been collected, but that nevertheless has influenced one on other variables in the study. I'm trying to think of an example of that one. Potentially, I guess maybe weather could be a lurking variable. We'll have to do some side research on that, because obviously none of us can control the weather either, or else all states would be Florida. Two variables are confounded when the effects of one cannot be distinguished from the effects of the other. Confounding variables may be part of the study, or they may be outside lurking variables. Okay, cool. We are almost done. We have one more little section to go. So any questions on surveys before I finish us up with our last mini section? Okay, I do want to finish up because then I have a couple of housekeeping announcements. All right, choosing data collection techniques. Obviously, we've discussed observational studies, experiments, and surveys. So which technique is best? It really depends on the number of variables of interest and level of confidence needed regarding the statements of relationships among the variables. That just basically means, so if we were to do some kind of project in here, which I haven't decided yet if we are or if we aren't, the most you would need would be a survey. You would do it on SurveyMonkey. I would get you a list of other student emails. You would obviously not bother them outside of the purposes of this class, and you would just email them your survey, and then you would compile the results. if you're thinking about something in the future, let's say if you end up going to a bigger school and you want to get into the honors program, or you're already in the honors program and they tell you that you have to do an honors thesis in order for you to graduate, you might want to consider more the observational study or the experiment over a survey. Okay, so the experiment is probably the most powerful, although it is the hardest to complete. Observational study would be the second most powerful, and then surveys are kind of not as powerful, but they can be a lot easier to work with. Okay, surveys may be the best choice for gathering information across a wide range of many variables. Many questions can be included in the survey. However, take great care to construct the survey instrument and in the administration of the survey. Non-responses and other issues discussed earlier can introduce a bias. Observational studies are the most convenient technique for gathering information on many variables. Protocols for taking measurements or recording observations need to be specified carefully. You guys can't record other students, so we're not going to go down that route. Experiments are the most stringent and restrictive data gathering technique. They can be time consuming, expensive, and difficult to administer. In experiments, the goal is often to study the effects of changing only one variable at a time. Again, anything you would do for an honors thesis or something like that, you would get approved by your honors mentor. So I mean, all of that information you would get in the future. But hopefully you would take all this knowledge with you and you will seem really, really smart when you talk about it. Because of the requirements, the number of variables may be more limited. Experiments can be designed carefully to ensure that the resulting data are relevant to the research questions. Okay, any questions on that stuff? No? Cool. Gonna stop.